we try to evaluate this expression here, that's scary looking expression. The braces here is a symbol for what is called fraction of x, commonly used function in number theory. So what is a fraction function? For a real number x, this symbol represents the fraction part of it. So mathematically, it's just subtract the floor of x. The floor function is the largest integer less or equal to x. Okay, so notice that the fraction for positive real number and negative real number are kind of different. Okay? 4.7 would be 0.7. Naturally, that makes sense. And negative number is actually not 0.3, rather it is 0.7 because that's the definition. Negative 3 is the floor, right? So that's the definition. Now, with that knowledge, pause the video and try to solve this problem. So this is a huge number here, and we try to evaluate the fraction of this expression from n equal to 1 to 20, 23. All right, pause the video and try to find the answer. Today, the problem of 2023 can be solved with some knowledge about modular arithmetic. In particular, we're going to look at some properties of the residue classes. Here, what is a complete residue system? For integer m, right, we say that a set of integers would form a complete residue system modulo m if every other integer is congruent modulo m to exactly one integer in the set. Now, typically, if we have 3, you know that the remainder is going to be 0, 1, or 2. So 0, 1, 2 form what is called the complete residue system. Of course, you don't have to use 0, 1, 2. If you use 1, 2, 3, that's also okay, right? Because either the remainder is 1 or 2 or 0. In the case, can be represented by 3. Right? Now, typically, we use 2 different forms of complete residue system. All right. For example, for integer 13, we know that the remainder could be 0 to 12. So this is a standard example of a complete residue system, right? However, another form, sometimes we want to examine the problem using the symmetric structure or property, then it is also so convenient to use this form. 12 is congruent to -1, right? 11, -2, and so on and so forth. And 7 and 6, right? 1 is positive, 7 is -6. This is sometimes more convenient to use than the standard one. So both are valid complete residue system because any integer will be congruent to one of the values in the set. Now, let's introduce some interesting properties. Okay, so that's useful for solving our problem is that if you have another integer a constant, and if you have a complete residue system here, right, for m, and then if you multiply each element by a here, we claim that the result is going to be a permutation of the original integers. Okay, in other words, this is still the complete residue system. Now, of course, how to prove this? Okay, we'll try not to be rigorous here, but the basic idea is that the key here is that the GCD of a and m is 1, right? So which means a has a multiplicative inverse mod m. So we can find the inverse here, right, for a. Now, each product, a times ri, has a unique residue mod m, right? So if you have different r, it cannot produce the same residue. It must be different. Okay, this is based on the first factor. Multiplication of a constant a to the residue class will produce another residue class. It's just permutation, different orders. Let's take mod 13 as an example, right? So here is complete residue class, and we multiply 6 because 6 and 13 is relative prime. So 6 times 0 equals 0, and everything else is kind of a permutation. Here is at 6, 5, 4, 3, 2 for these odd numbers, right? And for the even numbers, we have 12, 11, 10, 9, 8, and 7, the higher part of it, all right? So it's a permutation of it. So that's important property. And another important property is that if we add a constant a to the set, then it becomes what's called the cyclic shift of the residue class. The cyclic behavior ensures that the permitted set remains a complete residue because it's reordered, right? So if you add a constant to the complete residue class, the result is still a complete residue class. Now, for example, m equals 13, a equals 4, we add 4 to it, right? So 0 becomes 4, 1 becomes 5, this becomes 6. So it's kind of shift, right? And of course, when you shift 0 to 4, and this one, you add 4, it becomes 16, mod 13, that's 3. So this is shift to 3, right? This is called a cyclic shift, right? So here, 0, 1, 2 is shift here, and then 4 to 12, okay? So that's important property. Okay. With these simple properties, we can solve this seemingly complex expression here. This is integer 2023 at the bottom here. So for the fraction, we can ignore the integer part, this is a positive number. That's a huge number here. And so the result is going to be the remainder here matters. And the remainder, of course, is going to be either from 0, 1, 2, up to 20, 22, right? Now, for the summation, the n happens to have 20, 23 numbers here, right? From 1 to 20, 23. Notice that for 20, 23, when n equals 20, 23, and this multiple of 20, 23, so in modulus arithmetics, that's equivalent to 0. So in other words, the summation could be, treat this as 0. So it's going to be from 0, 1, 2, up to 20, 22, all right? So that's the summation will be the same, right? Because only modulus 2023 matters for the numerator here. Now, another key observation is that for this n varies, this number here happens to form a complete residue class, right, of 2023. And number 2000 is relative prime, right? So here, the GCD 2000 and 2023 is 1. So we can apply the first property, that is, if you multiply 2000 to the complete residue class, you get a permutation of residue class, all right? And furthermore, you add a constant. We apply the second property that is just a cyclic shift. So a cyclic shift of a permutation is still a valid permutation. That is, the result, it is the same as simply the residue class, 0 to 2023. How to calculate that? Of course, notice that the fraction here, we compare them. For example, 0, we ignore that because that's 0. And for the 1, we pair with 2022. Okay, they will add up to 1, right? And so for the ith term, we compare with 2023 minus the ith term. Okay, how many pairs can we form? Of course, that's going to be 1, 0, 1, 1's pairs. So the value we're looking for is 1, 0, 1, 1. That's the answer. Now, I do have a series called number 2023 challenges with different problems associated with number 2023. I used today's problem to introduce some fundamental concepts with modulus. That's very fundamental in elementary number theory. It might be useful for AMC and other tests. So for those who are new to the channel, please like, share, and subscribe to the channel.